Hello everyone, this session going to be on relation between roots and coefficients, symmetric functions of roots, and if I get time then I will be discussing Newton's method where a recurrence relation can be used to find the higher powers of roots of any equation, maybe quadratic, cubic or biquadratic. So without wasting time, let me start, which you might have little bit introduction in class 9-10 level. That for a quadratic equation, for any quadratic equation of this form, ax square plus bx plus c equal to 0, if its roots are alpha and beta, you have written, those who have not done it, for them I am writing it, alpha and beta given by the Sridhar Acharya formula, that minus b plus minus b square minus 4ac by 2a. And if you find the sum of these two roots, then alpha plus beta going to be minus b by a, alpha into beta going to be c by a. Okay? Now, what will be there for a cubic equation, for a quadratic, for a biquadratic equation, or equations of higher degree? That let us investigate. Before we proceed, let me write this equation in terms of alpha and beta. Because roots are alpha and beta, we can express this left hand side polynomial in the form a into leading term coefficient is a into x minus alpha, x minus beta. Okay? So now let us start with one polynomial equation whose degree is n. Like I am taking it of the form a0 x to the power n plus a1 x to the power n minus 1, a2 x to the power n minus 2, this way up to an equal to 0. This is the polynomial equation, px equal to. Now for this polynomial equation, if we take the roots or zeros of the polynomial of the left hand side as, let roots be alpha 1, alpha 2, alpha n. Because by fundamental theorem of algebra, you know that a equation, polynomial equation of nth degree has n roots, real or complex, that we don't know, but it has n roots, maximum number of roots, n minimum number of roots also n, exactly n roots are there. So if we use the method here for this equation to express it in the form of the roots of the equation, then we can write this as a0 x minus alpha 1 x minus alpha 2 x minus alpha n, isn't it? Our aim is to deduce the relationship among coefficients and the roots. Now if we go on expanding the right hand side, a0 x, all these first terms if you multiply, there will be x to the power n, nothing to compare over there on the left hand side. If we multiply alpha 1 with all the x's in the next bracket, it is going to be alpha 1, alpha 2 up to alpha n, x to the power n minus 1. Similarly, alpha 1, alpha 2 with the leading term, and then we repeat the process for alpha 2, alpha 3, alpha 3, alpha 4, the way we did here. Alpha 1 multiplied with the leading term here, alpha 2 multiplied with the leading term here, then it will be alpha 1, alpha 2, alpha 2, alpha 3, plus this way it continues. All the combinations taking 2 at a time will be there, and coefficient going to be x to the power n minus 2. Similarly, if we take alpha 1, alpha 2, alpha 3 terms like this, then we get product of the roots taken 3 at a time, alpha 1, alpha 2, alpha 3 plus alpha 1, alpha 3, alpha 4. It continues this manner, and it will be x to the power n minus 3. We will not continue. We will just write minus 1 to the power n minus 1. Now all these constant terms are multiplied. Then it will be alpha 1, alpha 2 up to alpha n. Okay? Now this is the time to compare the left hand side with the right hand side. The left hand side is here, the polynomial is 0 x to the power n like this, and here the right hand side you got. So if we go on comparing the two sides, that you can see that x to the power n minus 1 has coefficient a1, and here it has coefficient minus of this thing. So if we compare two sides, then we can write a1 equal to minus of this. Similarly, a2 will be equal to this thing, and this way a3 x to the power n minus 3, a3 will be equal to this thing, and an going to be this one. So if we go on comparing two sides, then we get minus of alpha 1, alpha 2 up to alpha n equal to a1. Therefore, alpha 1, alpha 2, not a1, this is actually the left hand side, we haven't expressed in that form because a0 is outside. So you need to take a0 common. You take a0 common, then you go on comparing, because right hand side there is a0, you cannot compare this manner. So if you take a0 common, then it will be x to the power n here, and this is a1 by a0 x to the power n minus 1, I am rewriting this one, plus a2 by a0 x to the power n minus 2, this way up to an by a0. Hope you have understood. Now if we compare two sides, this minus of this thing is going to be a1 by a0. So alpha 1, alpha 2, alpha 3, alpha n, if we transfer minus sign on right side, it is going to be minus a1 by a0. Similarly, if you take product of roots 2 at a time and then compare the coefficient of x to the power n minus 2, then alpha 1, alpha 2, alpha 2, alpha 3, this is all the product of the roots being taken 2 at a time. This is going to be a2 by a0. Okay? Now, we must favor the use of sigma sign. We want to write sum of all the roots taken one at a time using sigma sign. So how can we write this? If we want to write it by using sigma sign, that simply it is changing to sigma alpha 1 equal to a1 by a0. What about this thing? Product of the roots taken 2 at a time. So there it will be sigma alpha 1 alpha 2 equal to a2 by a0. So there is negative sign, no? So this will be equal to minus a1 by a0. Now for product of roots taken 3 at a time, we can write as, and now when we compare the coefficient of x to the power n minus 3, n minus x to the power n minus 1, n minus 2 and then n minus 3. Then there is a term here that I cannot write all the time, but it is there. It is, say, a3 by a0 x to the power n minus 3. Now compare this with the product of roots taken 3 at a time. I mean, compare the coefficient of x to the power n minus 3. Then this is going to be alpha 1, alpha 2, alpha 3. This I am not writing all the term. Instead, I will be using sigma alpha 1, alpha 2, alpha 3. Terms are like this: alpha 1, say arbitrarily alpha 4, alpha 6, alpha 7. All the terms taken 3 at a time are there. Then we will be getting this thing equal to, this is minus, no? So it will be minus a3 by a0. Okay. So sigma alpha you got here, that is sum of the roots. If you write alpha 1, it's fine. You can write sigma alpha also. Sometimes you write this. It is minus a1 by a0. Sigma alpha into beta, instead of taking alpha 1, alpha 2, if you take alpha beta, it will be a2 by a0, and sigma alpha beta gamma, this is going to be minus a3 by a0. Okay. So this way all the product of the terms taken 2 at a time, 3 at a time, 4 at a time, if you want to write alpha beta gamma delta, how to write this? Alpha beta gamma delta, product of the roots taken 4 at a time, this is going to be a4 by a0. Okay. And if you take all the roots together, if you multiply them, then you will be getting this thing, alpha 1, alpha 2, alpha n. This is going to be an by a0. So if you rewrite that, it will be alpha 1, alpha 2, alpha n equal to minus 1 to the power n minus 1 is there. It is an by a0. Transfer this thing on right side, multiply it, then you will be getting sigma alpha 1, alpha 2, alpha n equal to minus 1 to the power n minus 1 an by a0. Okay. Understood? Now we are going to define a function which is known as symmetric function of root. What is symmetric function? Symmetric function, if you have done function in two variables, a function of the form fxy equal to, if xy equal to x plus y plus z is said to be symmetric. If xy equal to x square plus y square plus z square, symmetric. If xy, x square y, y square x, in terms of two, this you have taken in three variables. Because you have written z over there, this is also in three variables. So this is symmetric function in three variables. Why? Why they are called symmetric functions? It is because if you exchange any two of them, interchange x and y or y and z or z and x, the expression will remain the same. It is called symmetric function in three variables. What about this thing? If xy equal to x square y plus y square x, this is symmetric function in two variables. a symmetric function in two variables. This is symmetric function in three variables. Now let us take another one. But definition you should remember, if we interchange any two variable, the expression doesn't change, then it is said to be symmetric function. Like we are taking, if x, y, z is equal to x square y plus z square x. Is this symmetric? This is not symmetric function. Symmetric function. Why? Because if you just simply change x and y here or x and z here, it will be changed. If you interchange that x and z, say you are interchanging, then you will be getting the function in the form z square y plus x square into x. Sorry. So this expression will not match with x square y plus z square x. That's why this is symmetric function. This is not symmetric function in x, y, z. In case of roots, suppose we are taking alpha, beta, gamma as the roots. Then if alpha, beta, gamma, this is going to be, say, alpha cube beta gamma plus beta cube gamma alpha plus gamma cube alpha beta. You interchange any two variables, then expression will remain the same. This is a symmetric function in three roots. Symmetric function of alpha, beta, gamma. Okay? Now, if symmetric function is there, every term has the sum of the indices same. Like 3, 1, 1. Sum of the indices going to be what? 5. Here it is 5. Here it is 5. 1, 1, no? So this thing will be the same. Or you remember this manner that interchanging any two variable, expression doesn't change. Okay? Now before we proceed, we should check this symmetric function. What is the use of this symmetric function? How to tackle an expression containing symmetric function? That maybe it is given alpha, beta, gamma are the roots of a cubic equation. You find the value of this thing. It is symmetric function. Its value you can find. But if it is asymmetric, we won't be able to get it. You have to get a symmetric function over there. Okay? Before we start solving sums based on it, just let me rewrite again by using symmetric function for a quadratic equation for a cubic equation. Let me write that a0 x cube plus a1 x square a2 x plus a3 equal to 0. Its roots are alpha, beta, gamma. How to write sigma alpha here? As you have seen before, a1 by a0. Sigma alpha beta is what? a2 by a0. Sigma alpha beta gamma we need not write because it is three roots only. This will be minus a3 by a0. Alternate plus minus. For a biquadratic equation, how to write? a0 x to the power 4, a1 x cube, a2 x square, a3x plus a4 equal to 0. Sigma alpha is going to be what? Minus a1 by a0. Then sigma alpha beta going to be what? That is a2 by a0. And sigma alpha beta gamma has a meaning over there because 4 roots are there. Those roots are alpha, beta, gamma, delta. You have to consider combination of all the roots. Like here, if I simplify it, it is alpha, beta, gamma plus alpha, gamma, delta plus alpha, beta, delta plus beta, gamma, delta. 4C3, 4 combinations are there. We can write sigma alpha beta gamma in this manner. And what about sigma alpha beta gamma delta? It will have only one term, that is alpha beta gamma delta itself. This is going to be A4 by A0. Okay? Now let us solve some sums based on it. Before we proceed, we just check whether sigma 1 by alpha, which is actually 1 by alpha for a cubic equation I am writing. You can write for biquadratic also. 1 by gamma, 1 by delta. Is it symmetric function of root? You decide it yourself whether it is going to be symmetric function or not. Like another one, sigma alpha by beta plus gamma. It will be alpha by beta plus gamma plus beta by, I am writing it for cubic equation. A0. This I have done for biquadratic equation. A0 x to the power 4, A1 x to the power 3. This way up to A1, A2, A3, A4 equal to 0. And this one I am writing for cubic up to A3 equal to 0. Then beta by gamma plus alpha, gamma by alpha plus beta. Are they symmetric? They are all symmetric, because the definition we should remember, if we interchange any two variable out of this, the expression is not going to be changed. It will remain the same. That's why they are all symmetric functions of roots. All symmetric functions of roots. Okay? Now, by remembering this, I will be writing the nth degree polynomial and the general method of finding these kind of in finding the values of this kind of symmetric functions. Okay, so we start this manner. Let alpha 1, alpha 2, alpha n be the roots of A0 x to the power n, A1 x to the power n minus 1 plus n equal to 0. These are the roots of this. You find the value of number 1, sigma alpha 1 square or sigma alpha square. Number 2, say sigma alpha 1 cube. And number 3, we are going to find, say, sigma alpha 1 square alpha 2. How to find their values? Understood what I am going to find? Alpha 1, alpha 2, alpha n are the roots of this equation. You have to find the value of sigma alpha 1 square, sigma alpha 1 cube, sigma alpha 1 square, alpha 2. See how to find it? For finding sigma alpha 1 square, we start with this. Sigma alpha 1 into sigma alpha 1. What it is going to be? Alpha 1, alpha 2, alpha n into alpha 1, alpha 2, alpha n. isn't it? Why have I taken this product? Because when you are going to multiply opening the brackets, you'll be getting terms like this, alpha 1 into alpha 1. This is alpha 1 square. Plus alpha 2 into alpha 2 square. Plus alpha n square. But not only these terms, alpha 1, alpha 2 there, alpha 2, alpha 1 is there, alpha 3, alpha 2 there, alpha 2, alpha 3 there. So all these products taken two at a time, coming twice, each term coming twice. So you can write this as alpha 1, alpha 2 plus alpha 2, alpha 3. I cannot write all the terms. I will be using sigma sign instead. Alpha n minus 1, alpha n. Okay? So what it is going to be? Therefore, sigma alpha 1 into sigma alpha 1, it is sigma alpha 1 square, and this one 2 sigma alpha 1 alpha 2. Am I correct? So you got sigma alpha 1 into sigma, this is not sigma alpha 2, you can write similarly, no difference here. Any one of them can be representative when you are writing sigma. Normally we write the starting one. Sigma alpha 1 means alpha 2, alpha n, alpha 2 plus alpha 3 plus alpha 1, alpha n, all these sums. But if somebody writes sigma alpha 2, it has the same meaning. Now sigma alpha 1 square, you got sigma alpha 1 into sigma alpha 1 minus 2 alpha 1 alpha 2. What is sigma alpha 1 for this? Some of the roots, as we have seen, minus a1 by a0 into minus a1 by a0. And what is sigma alpha 1 alpha 2? a2 is there, a2 x to the power n minus 2. So it will be plus a2 by a0. Hope you have understood. a1 square by a0 square 2a2 by a0. Finally, sigma alpha 1 square is going to be a1 square minus 2a2 a0 by a0 square. Is that clear? So try to understand the simple logic here. We have multiplied sigma alpha 1 with sigma alpha 1 to get sigma alpha 1 square. Our strategy for next one, sigma alpha 1 cube. How will I find it? Sigma alpha 1 cube, doing it here. How to start this? Sigma alpha 1 cube, we start with sigma alpha 1 square, because sigma alpha 1 square we already got, we multiply these two. What will happen? Let us check. Why? Because I have to get this in the product on right side. This is alpha 1 square, alpha 2 square, alpha n square into alpha 1, alpha 2, alpha n. Okay? So this is going to be what? This is alpha 1 square, alpha 1, alpha 1 cube, alpha 2 square, alpha 2 cube. So we are definitely getting sigma alpha 1 cube. What extra you are going to get? See, alpha 1 square, alpha 2 there, alpha 2 square, alpha 1 there, alpha 1 square, alpha 3, alpha 2 square, all these are there. So this will be writing as, question arises, will I get sigma alpha 1 square, alpha 2 twice? You take time to think. We'll get once only, because alpha 1 square alpha 2, it is not going to be repeated. Alpha 2 square alpha not going to be repeated, but all the variations are there. So by starting with sigma alpha 1 square into sigma alpha 1, we definitely got sigma alpha 1 cube. But another term has come which is actually requirement of the problem, to find sigma alpha 1 square alpha 2. How you start with sigma alpha 1 square alpha 2? For this thing you start with sigma alpha 1 into sigma alpha 1 alpha 2. What will you get? Alpha 1, alpha 2, alpha n, then alpha 1, alpha 2, just a minute, alpha 1, alpha 2, alpha 2, alpha 3, this is all, alpha n minus 1, alpha n also there, all the terms are there. If you multiply all the terms, then you see it is coming to be alpha 1 with alpha 1 alpha 2. It will definitely give us sigma alpha 1 square alpha 2 form. But there are terms like alpha 1, alpha 2, alpha 3. Again, alpha 1, alpha 2 and alpha 3. Is a value over there, alpha 3 is there, I did not write it, alpha 3 is there, isn't it? So sigma alpha 1 square alpha 2 is coming as it is, because alpha 2 square, alpha 3 will be there, alpha 3 square, all these things will be there. But in addition to that, there is alpha 1 into alpha 2 into alpha 3. That is clarified. But the question is, how many times will be occurring? Now, if you multiply alpha 2 with alpha 1, alpha 3 here, you will be getting it. Similarly, alpha 3 with alpha 1, alpha 2, you will be getting. So, in general, if you combine alpha 1, alpha 2, alpha 3, then it is coming thrice. So this thing going to be 3 into sigma alpha 1, alpha 2, alpha 3. Therefore, sigma alpha 1 square alpha 2 going to be sigma alpha 1 into sigma alpha 1 alpha 2 minus 3 sigma alpha 1 alpha 2 alpha 3. Don't remember this one as formula. Remember this one as a method. Okay? Sigma alpha 1, you know, that for the nth degree equation as we have written before, minus a1 by a0, you know, and this is what? a2 by a0, and alpha 1, alpha 2, alpha 3, again minus a3 by a0. So this thing is changed to 3a3 a0 minus a1 a2, that divided by a0 square. You substitute the value here which we have left over there, because sigma alpha 1 square alpha 2 was coming. So sigma alpha 1 square alpha, our aim is to find sigma alpha 1 cube. So there will be sigma alpha 1 cube equal to sigma alpha 1 square sigma alpha 1 minus, you know the value, sigma alpha 1 square we have just found, sigma alpha 1 square we got here, sigma alpha 1 is no, and sigma alpha 1 square alpha 2 also you got here. What is sigma alpha 1 square? a1 square minus by a0 square. And what about sigma alpha 1 square alpha 2? You got it here. Hope you have understood how to find. So strategy is simple, very simple. Sigma alpha and q we are finding. That's why I've started with sigma alpha and square into sigma alpha 1. And sigma alpha and square alpha 2 was required. We have started with this product, sigma alpha 1 into sigma alpha and alpha 2, because we are sure that we'll get a term like sigma alpha and square alpha 2. Today is till this only. Next session I will be coming with many problems based on this concept, symmetric function of roots. And then in addition we are going to learn Newton's formula, recurrence relation actually, to find any higher degree of roots, their sum, maybe product, that I will discuss. Okay, thank you.